Okay, good evening everyone. I welcome you all for this data science session 2. One second. Okay. Okay. Today in this session, we'll be looking at some of the basic functions that we'll be working in Pandas. Okay. So we'll start with how to work with data frames in Pandas. Okay. So a data frame is basically a table, okay, a table of data which is having rows and columns. Okay. As you can see from here, this is simple coding which will give you a table of data. So I am doing import pandas as PD. PD is the short name for pandas, and D equal to I am giving here column 1 equal to an array of data, okay, list of data. This is the data which will be displaying in the column 1, and this is column 2, and this is column 3. Okay, and I'm going to create a data frame now using this function. PD is the short name for pandas object, and PD dot data frame. I am supplying this data D here. Okay, data equal to D. Okay, so with this data it will be creating the data frame, and it is stored in the variable called df. Okay, now I am going to print this data frame, so your output will be like this table. Okay, so you'll have column 1 equal to 1 2 3 4 7, so that is the data given in this data D, and column 2 equal to 4 5 6 9 5, so as it is given in the data, and column 3 equal to this data. Okay, so this is the output you will be getting it. And the next thing we are going to see is how you are going to count the number of rows and columns which is available in the given table. Okay, now we have created a simple table, and we are going to find out the number of rows and columns which is available in the table. Okay, for that we have a function called shape. Okay, so column equal to df dot shape of 1. If you give 1, you will get the number of columns which is available in the table. Okay, so let's try to implement this, and we'll see whether you are getting the output or not. Okay, so this is my Google Colab notebook. So I have done already some codings here. So this is the code we have seen just now in the PPT. So I am just running this so that you will get this output, whatever we have created now, the table. Okay, so what is the data given here? That is created as the table here. Okay, now we are going to find out the number of rows and columns. Okay, so there is a function called shape. I told you df dot shape of, if I give 1, it will give you the number of columns. The number of columns is 3, column 1 2 3. Okay, so if I give you 0, it will display the number of rows in the table. So how many rows are there? There are 5 rows. Okay, so that function, the shape function, will give you the number of columns and rows, depends upon the index we are supplying. Okay, then we are going to work with a small data set that is called sports watch data set. Okay, so this is nothing but something like you are wearing on your smart watch, the smart watch, a smart band which is recording simple informations like how many steps you are walking per day, and how many hours you are working, how many hours you are sleeping, then what is your pulse rate, how many calories you have burned. Okay, these kind of details. Okay, so the data set which is given over here has the details like duration is the time, how much time you are working out every day, 30 minutes, 45 minutes, 60 minutes, something like that. Then average pulse, maximum pulse, then calorie, how much calorie you burn, and then hours working, what is the working hours and sleeping hours. Okay, so this is the data we are having, simple data set. With this data set only we are going to do some basic operations using pandas. Okay, so these are all some of the basic functions. We are having max, min. Okay, so when I apply this max, it will give you the maximum number which is available in the given data. Okay, and then the next one we have minimum, which will give you the minimum in the given data. Then we have a function called mean, okay, which will find out the average of the given numbers. Okay, so for this I am going to use a function called np.mean. Okay, as you can see here, I am importing this numpy. Okay, and this is the values I am having. Okay, calorie burnage equal to some set of values are there. I am going to calculate the average of these values using this numpy package. Okay, so np.mean, give the array name here. Calorie burnage is the list in which I am having the numbers. Just apply the list name so that you will find out the average of the given values. Okay, so when you run this, so you will be getting the mean value. Okay, then then we'll see how to read an Excel file, or you call it as CSV file. Okay, CSV stands for comma separated values. Okay, so this is also looks like an Excel file. You can open this CSV file in Excel, or you can open this in Notepad also. Okay, so when you open this CSV file in the Notepad, what happens? For example, if the file is having three columns, roll number, name, marks. Okay, then what will happen? These details will be separated by comma. Okay, in the Notepad. If you open in Notepad, if you open in Excel, then there won't be any commas. It will be showing like rows and columns. Okay, then there won't be any problem. So if you open in Notepad, the values will be separated by comma. So that's why it is called comma separated values. Okay, so now let's look at how to import a CSV file into your Python program, and how to read the data from the CSV file. Okay, so that's what we are going to do now. So this is my simple coding which will read the data. Okay, so import pandas as PD. Then I am going to read this file that is called dirty data.csv. Okay, because this file doesn't have any proper data, it has some errors, so that's why it is called dirty data. So now I am going to read this file, content of this file, using this function read csv. Then you give the file name. Okay, so this content will be loaded into this variable health data. Okay, now whatever available in the file, that will be loaded into this variable. Okay, now I am trying to print this data. Okay, now you are getting some error. What is the error you are getting? File not found. Okay, since you are working on the online platform, you need to load the file. Okay, if you are working in your local machine, if you have installed Python, yesterday I told you know how to install Python. So if you have installed Python in your machine, and you can run this if your file is available in the same folder where your program is available. Okay, then you will not be getting this error. Okay, now my job is I need to load the file. Okay, so as you can see here, there is a folder button here. Okay, so click on this button. Okay, now there is a upload button here. You can see, click on this button. Okay, now we can go to the folder and load your file. my file is loaded. So my file is available here, dirty data.csv. Okay. So now you try to run this code. Okay. See, now you are getting the output. Okay. So it has 0, 1, 2, 3, 4, and there is some dots shown here. Okay. And then it is continuing like 83, 84 till 87. Okay. So it has 88 rows and 5 columns. Okay. So as you can see, I'll show you the one second. I'll show you the data set. Okay, this is your data set. As you can see, one second. Okay, so I have duration, date, pulse, maximum pulse, then I have only calories. Okay, now see, as you can see, some of the null values here. Okay, some of the values are missing. Okay, we will see how to handle these data. Okay, using pandas. So the same data has been displayed here. Okay, 0 to 4, and then it's not displaying the full data. You can see around 88 rows will be there. Okay, so this 88 rows will be displayed. Okay, now because of the space constraint, it's displaying only the top 5 rows and last 5 rows. Okay, no, I don't want to do like this. I want to display all the rows. Okay, then what should I do? I can write a function like this: health data. I will comment this one, health data dot toString. You just give dot toString, it will display the full data. As you can see, it starts from 0, 1, 2, 3, 4, it goes till 88. Okay, 87 rows. Okay, so that is the use of toString function. Okay, so when you give toString, it will display all the rows without hiding any rows. Okay, the next one we have is, there is a function called head and tail. Okay, let me see what it does. Okay, now what I do, health data dot head, just print this. Okay, as you can see here, it displays only the first 5 rows. Okay, so when I give head, it will display only the first 5 rows, and similarly when I give tail, it will display the last 5 rows. Okay, 83 to 87. Okay, now for example, I want to display the last 10 rows. Okay, so you can give tail of 10. You can see from 78 to 87, last 10 rows will be printed. And similarly, if I want first 10 rows or first 12 rows, I am giving head of 12, so it will give you first 12 rows, 0 to 11. Okay, so that is the purpose of head and tail functions. Okay, now let's look at some basic cleaning in the data. Okay, so cleaning is nothing but there may be some null values, so how to remove that null values. There may be some error values, so how to handle the error values. So this is nothing but some basic cleaning of the data. And if you are having a null values, what you are going to do? Okay, So there is a function called drop NA, which will remove the rows which are having null values. Okay, so that is the function of this drop NA function. So let me go to this. You can see here health data dot drop NA axis equal to 0 and in place equal to true. Usually it will be in place equal to true. Then you print health data. Okay, now I am going to run this. As you can see here, there is no row 2 displaying. Okay, look back at the previous data. You can see row number 2 is having null values. Nan is there, no? So here I have one null value and here I have one null value. Okay, so and row number 5 also is having null values. Okay, so all these rows will be removed. Okay, wherever you are having null values. Okay, so you can see the row number 2 is not present here, and similarly 82, 83, 84 is also not present here. Okay, because 84 also may be having null values. Okay, and similarly row 5 also missing, that is also having null values. Okay, you can see here row 5 is having only one null value. Okay, and row 2 is having two null values. Okay, even if you have one null value in one place, then it will be removed, the entire row will be removed. Okay, so that is the purpose of this drop NA. So axis equal to 0 means the row will be removed, axis equal to 1 means the column will be removed. Okay, so if you remove the column, it's very illogical. Okay, there is no logic in that, because for example, if I have null values in the calories column, if I remove the calories column, what will happen? The entire data which is available in the calories column will go off. Okay, because the data for the other people also will go off. Okay, so you need to remove only the rows, not the columns. So that's why we are using axis equal to 0. Okay, then there is something called in place equal to true. Now for example, I am going to give false. Okay, in place equal to false, then what will happen? So this is my original data. Okay, now I am going to run this in place equal to false. As you can see here, the row 2 is not removed. Okay, even if you are having null values, the row is present. Okay, and similarly the row 84 is also present, the null value is present, but we are using drop NA only. We are removing the rows, but it is not affected. Okay, if you put in place equal to false, but the rows are removed, but we are not getting it affected here. Okay, so what I'll do, I'll create one variable, for example x equal to health data dot drop NA. Okay, and then I am printing this x. Now let's see what happens. Now see here, the row 2 is not available, and similarly 84 is not available, the null values are removed. Okay, so actually when you use drop NA function, the rows which are having null values are removed, whether it is in place equal to true or false, it is removed. Okay, and it is returning some data set. Again it is a table, and that result will be stored in the x. Okay, and if you print x, that gets displayed. Okay, this is when you put in place equal to false. So when you put in place equal to false, what happens? it will not go and change in the original data set. The original data set is health data. Okay, so this is the variable. It is not changing in the original data set, but it is returning some result, and we can store that result in the x variable, and then you can print that result. Okay, but when I give in place equal to true, okay, I can print health data here. Okay, now when I run this, now you can see the row 2 is removed, and similarly 84 is also removed. Okay, so it is affecting the original data, that is the health data. Okay, so that's why you will have to give always in place equal to true if you want to make changes in the original data, health data. Okay, so that is the purpose of in place equal to true. Okay, okay. Then there are three categories of data we'll be handling in data science and machine learning. So one is numerical. Numerical, basically there are two categories. Okay, one is integer, the another one is floating point values. Okay, so integer is the whole numbers, as you all know. Okay, for example 100, 25, 46, something like that. And floating point numbers are decimal values. Okay, 7.23, 16.48, something like this. Okay, and the next comes categorical data. Categorical data is, it's something like everything is a different class of data. Okay, for example I can see a set of colors. Colors is black color, white color, green color, yellow color. Everything is separate classes. Okay, everything is separate category. There is no relationship between the category. Okay, and you can see subjects, maths, physics, chemistry, something like that. Everything is a separate classes. Okay, but when you come to ordinal data, it is also a categorical data basically, but there is some relationship between the data. For example, you can take your grading system in your college or school, whatever it is. Okay, A grade, B grade, C grade, something. Okay, so if I say A grade is the mark is 90, maybe more than 90, and B grade is more than 80. Okay, and there exists a kind of a relationship between the data. For example, A grade is better than B grade, and B grade is better than C grade, C grade is better than D grade, something like this. Okay, so that kind of relationship is not there in categorical data, but in ordinal data that kind of relationship will be there between the datas. Okay, so these are all the three kinds of data we will be handling in mostly in data science and machine learning. Now there is a function called info which will give you some basic information about the data which is available in your data set. Okay, for example I am going to use this info function, health data dot info. As you can see here, this will give you some table output. The table shows the column names and then some set of values. Okay, I'll do this without doing this drop NA, then you will be able to understand. Okay, okay, 1 second. I have commented this drop NA. I am executing now. Yeah, you can see here. So which will show you the column names, and the next column is there is some numbers displayed here, 87, 88, 88, 87, then 78. Okay, so this shows the number of non-null values in the column. Okay, for example, if you take duration column, it shows 87. There are totally 88 rows. It shows 87. It means that there is one null value in the duration column. And date, pulse, maximum pulse, there is no null values available. And color is 78 non-null values. So it means that there are 10 null values available in the calories column. Okay, so that numbers will give you the number of non-null values. Okay, the next column shows the data type of each column. Duration is floating point, date is object, pulse integer, maximum pulse integer, and calories is object, sorry, floating point. Okay, now out of this, as I already told you, the data science or machine learning algorithms will be able to handle only a numerical data, okay, integer or floating point. Okay, it will not be able to handle any object type or string type. For example, you cannot feed your name or a date to the machine learning model, and you cannot train the model. Okay, the model will be able to handle only numerical or categorical data. Okay, so if you have this kind of data, object data, you need to convert that data into a format which is handled by your algorithms, okay, machine learning models. Okay, so how do you do that? As you can see here, in this data, I am having two objects, average pulse and maximum pulse. Okay, so there is a function called as type. Okay, as type is which is used to convert into a different format, that is objects into different format. Okay, so here health data of, give the column name, which column you want to convert. Okay, average pulse dot as type, which this is the function used to convert to which type you want to convert. I want to convert it into float. Okay, similarly the maximum pulse column also, health data of maximum pulse dot as type, you give float. I want to convert that into float. Why? Because these two columns are displayed as object, average pulse and maximum pulse. Okay, so I want to convert these two into a floating point so that the machine learning model will handle the data. Okay, so after doing this conversion, converting object into floating, you can see the output here. Again I am giving health data.info, so you are getting the output as average pulse floating and maximum pulse also floating. All data are floating now. Okay, so this is how we can convert the object types into floating point types. Okay, then there is a simple function called describe, which will give you all the basic statistics about your data set. Okay, so you just give only one word which will do a lot of work for you. I am going to give just health data dot describe. Okay, and execute now. As you can see here, I have duration, pulse, maximum pulse, and calories. There are 4 columns, and these are all the basic statistics which is derived from the data set. Okay, count is the number of non-null values for the column. Okay, so there are 87 non-null values, 88, 88, and 78. Okay, and similarly mean is the average of this column, duration column average, and this is pulse column average, and similarly this is maximum pulse average, this is calories average. Okay, STD is the standard deviation for that respective columns. Okay, and minimum, the minimum value in that column, respective column, and maximum is the maximum value of that respective columns. Okay, and these three are called percentiles. Okay, there is something called 25 percentile, 50 percentile, and 75 percentile. There is some statistics in your max. Okay, so which will give you the percentile values. Okay, so with this a single word describe, we are able to get this much basic statistics about the data set. Okay, so that is called a describe function. Okay, okay. So this is about the basic uh, working with pandas data set. Okay, so what I have done today is I have loaded a simple data set. Okay, basic data set, and I have read the data set using a read CSV function, and we'll be able to do some basic cleaning. Basic cleaning in the sense we are just removing the null values using drop NA function, and we are getting some information about the data set and how to convert into object into different types, and how to get the basic statistics about the data set. Okay, so this is what about today's session is. Okay, and in the next coming session we'll be looking at about a NumPy package. Okay, so let's close the session for today. We'll see about NumPy in the next class.